All right, so I keep telling you guys that we are eventually going to work our way to a place where we're going to work backwards from multiplying. The double distributing, the single distributing, and all that kind of stuff. And so we start that now. We want to talk about factoring today. Factoring is taking a polynomial and breaking it down into the multiplication of other polynomials, right? So, quick review. It's part of what we took a test on last time. Go ahead and take a second and multiply these out. You can stop the video, start it back up, just check your work, and then we'll move on into our factoring. Okay, so hopefully you remember that here we're going to FOIL, right? First times first, outside times outside gives you negative 7x, inside times inside gives you 4x, and then your last term is negative 28. Those middle terms, your outsides and insides, give you like terms, at least in this situation, and so you got to simplify down to that, right? Same thing here, outside times outside gives you 2x squared, first times first. And then outside times outside gives you negative 8x. Inside times inside gives you 1x. And then last times last gives you negative 4. Combine those like terms, you get 2x squared minus 7x minus 4. All right? All right, so to get into our factoring, we're going to start easy, right? When I say start easy, we're going to want to talk about factoring a monomial out of a polynomial. In order to do that, we have to know what a GCF is, right? A GCF is the greatest common factor, right? Remember what a greatest common factor is. If I give you two numbers like 24 and 36, the greatest common factor has got to be the largest number that will divide evenly into both of those, right? And so you got to start thinking about this a little bit. I'm looking for the large number that will go into both of those. I know that 12 will go into 24 and 12 will go into 36, right? But I don't think there's anything bigger that will go into 12. 24 won't go into 36, right? So since 12 is the largest number going to both of those, 12 would be your greatest common factor. That's what we're looking for, right? The biggest number that I can divide into whatever it is I'm talking about, right? So if I'm looking for the greatest common factor for 24x squared y to the third and 8xy to the fifth, okay? I'm looking for the largest monomial, which could be a mixture of numbers and variables, that I can divide into both of those. Right? Well, the coefficients first. The largest number that will go into both 24 and 8 is going to be 8, right? I can divide 8 into both of those. So I want to make sure I divide that out, right? Now, in terms of what will divide into both with the variables, right? I can divide x squared by x. That's no problem, right? We know that when we divide like bases, we subtract the exponents, so we just get x when we do that. And I can divide x by x. X divided by x is just 1. Okay? I can divide x squared by x squared, but I can't divide x by x squared. Because even when you subtract the exponents, you get like 1 over x. And that's just weird. We don't want to do that, right? So what we're looking for is we're looking for the most number of x's that they both have in common. This one has 1x. This one has 2. So the most they have in common is 1x, right? And then the same thing with the y's. The most number of y's they have in common is 3. So your greatest common factor is going to be 8xy to the third. Okay? Same thing with number 4. I need the biggest number to divide into both, 5 and 15. And that largest number to divide into both is going to be 5. And the number of x's that they both have, right? This one's got 2, this one's got 3. So that means that they both have at least 2. Obviously, this one has more than 2 x's, it's got 3. But since this one only has 2, then our greatest common factor is going to be x squared. Okay? Out of number 5. Now we've got 3 terms. numbers first. It's always easiest numbers first. The large number divided by 3, 9, and 15 is going to be 3, right? Now, the most number of x's that they all have in common. This guy has 2, this guy has 1, this guy has none. So they actually don't have any x's in common, right? So we're not going to be able to use x as a greatest common factor. They don't have any in common. Okay? Unlike number 6, where you got 2, 12, and 16. The greatest common factor there is 2. 2 is the biggest number divided to all of those. Since this guy has 2 x's, this guy has 1, this guy has 4, they have 1 x in common. They all have at least 1, so that's the x they have in common. So this is going to be 2x. So our greatest common factor is just going to be 2x. Okay? Does that make a little bit of sense? That's what we'll divide into all of them. Okay? Now, if I want to factor out, so I want to factor out a greatest common factor, I'm still looking for what I can divide into all of the terms. The biggest number that I can divide into these two terms, the 4 and the 24, is 4. Right? The most x's that they have in common is 3. So 4x to the third is going to be my greatest common factor. Okay? Now, if I divide out 4x to the third from both of these, I just said I can do that. Then what would you get, right? In this first term here, 4 divided by 4 is 1. If you divide the x's out, you subtract 4 minus 3, and you would get 1. So there'd just be 1 x left. Now, same thing here. 24 divided by 4 would be 6. 3 minus 3 is 0, so the x to the thirds divide out. So you'd have a plus, and then there would be a 6 left. Okay? That's what you would get if you divided 4x to the third into both of those terms. Okay? Now, the idea is I'm trying to break this down into factors, kind of like 24. If I were going to factor this down, I could factor it into 2 and 12. And that's because 2 times 12 would give me 24. Now, these are two factors, 4x to the third and x plus 6, that if I multiply them together will give me 4x to the fourth plus 24x to the third. So I got to make sure I create this multiplication problem when I'm done factoring. And so this is what that would factor down into. This monomial times a binomial, 4x to the third times x plus 6. If I distributed this back out, which I'm not going to do, but if I did, I should get back to 4x to the fourth plus 24x to the third. I should get back to the original problem. Okay? But since I want to factor it down, my final result will just be these two guys multiplied together. Okay? Do another one with a little bit less illustration there, right? All right, I need the greatest common factor first. What will divide in both 8 and 24? Well, 8 will. That's the biggest number that will go into both. They both have at least one y in common, so that's going to be part of my greatest common factor. And then I'm going to create a binomial that if I distributed the 8y into it would give me 8y squared minus 24y. And the way I do that is just divide both of these guys by 8y. Okay, so divide both these terms by 8y. When you do, 8 divided by 8 is 1. Y squared divided by y, just subtract them, or we're going to take a y out of there, and you get y. Minus 24 divided by 8 is 3, y divided by y is 1, so we're just left with y minus 3. If you distribute 8y into y minus 3, you'll get back to 8y squared minus 24y. But you need both of those. Okay? All right. Quicker still. Biggest number that will divide into 2 and 8. That's 2. The x's that they have in common, just one x, right? So now divide 2x by 2x. 2 divided by 2 is 1. You take an x out of x squared, and you're left with 1. 8 divided by 2 is negative 4. The x's divide out, so we get 2x times x minus 4. Okay? Starting to get the hang of it? Try 11. Stop the video. Pull out your greatest common factor, divide the two terms out by that greatest common factor, and create your other polynomial to multiply by. Then start the video back up, and I'll walk you through it. Okay? All right. So your greatest common factor, 3 will go into both of those, and they have one s in common. I know this guy has 2, but this guy doesn't. He only has 1, right? So now divide both of these by 3s. That'll give you 1. This will give you s. Minus 9 divided by 3 is 3. S divided by s is s. And so s minus 3. So it's almost like you're taking one s out of each term in what you're going to have left over when you do that. Okay? All right? Oh, man, bigger. Even with 4 terms, this is the same process. Figure out what the biggest number to divide into all of those and how many r's they all have in common. Right? The biggest number that will divide into all 4 of those, 2, 14, 6, and 20, is 2. And then if you look through that, the most r's that they all have in common is 1. So we're going to pull 1 r out of each of those terms. And we're going to divide a 2 out of each of those terms. So maybe this is a little bit easier if we don't write it all out. 2 divided by 2 is 1. If I pull an r out of the 4 there, I have 3 left, so r to the third. Negative 14 divided by 2 is negative 7. Take an r out of 3, and you have 2 left. 6 divided by 2 is 3. Take an r out of 2 there, and 1 is left. 20 divided by 2 is 10. Take an r off of that one, and there aren't any r's left, so we just make this r. And we're done. It's the same process, even with more terms. Okay? All right, you try 14, come up with the greatest common factor, pull it out, and then come up with your new trinomial. Stop the video. Check your work when you're done. Okay, greatest common factor. Well, 3 won't go into all 3 of those. 3 won't go into 5. 5 won't go into 3 or 18, right? So there's not a number that we can factor out of this, right? How many x's do they all have in common? Well, none. So there is no greatest common factor. Since that is the case, at least for right now, we're going to say this is prime, right? Remember a prime number like 7 is a number that will factor only into 1 and itself. It's the same thing. We can always factor out a 1, but a 1's not going to change anything. So we call this guy prime. Okay? All right. Try 15. See what you come up with. Stop the video, start it back up, and see if you're right. Okay, your GCF. A 3 will go into all of those. They have 1 x in common. They have 1 y in common. Yeah, we can do 2 variables at the same time. It's okay. Now, just divide out the 3xy from all of your terms. 3 divided by 3 is 1. We take 1x out of that 5. We get x to the 4th. We could put a 1 here, but typically we don't write it if the coefficient is 1. Take a y out of those 3. You have 2 left. Right? Now, negative 15 divided by 3 is negative 5. Take 1x out of those 2, you have 1x left. Take 1y out of those 2, you have 1y left. Here we go, plus the 3 divided by 3 is 1, which we could write the 1 if we want, but let's see, 3 divided by 3 is 1, x, you take an x out of there, and there's no x's left. If you take a y out of there, there's no y's left. So you would have a 1 and then no variables. So you actually do need that 1, right? The only time you don't need the 1 is if there are a bunch of variables that are there with it. Okay? So if it makes you feel better to go ahead and say 3 divided by 3 is 1 and put that 1 there, and then see what happens with the variables, that's okay too. There you go. All right? Not to mention, if you try to divide this out, 3xy divided by 3xy, all that's just going to turn into a 1. It doesn't go away. It's 1, so we need that plus 1 there. Okay? All right. Last one, best one. Stop the video, start it back up, and see if you got it right. Okay, how about it? Did you come up with 4x as your greatest common factor? And then when you divide a 4x out of all those, you would get 4x to the third plus 2x plus 5. Does that make enough sense? Hopefully it does. Homework sitting out in Canvas. Use your notes to help you with that homework, and we'll talk about it next time.